Hi everyone, today we're going to be talking about terms and arithmetic sequences. So the first thing we're going to talk about is what is an arithmetic sequence. An arithmetic sequence is just a set of numbers where each time or the next number is either adding something to the previous number or subtracting something from the previous number. That's why it's called arithmetic. So arithmetic means adding or subtracting. A good example of an arithmetic sequence would be like 2, 4, 6, 8, 10. I could continue on, but in this case, each time I'm adding 2. So to get from 2 to 4, I have to add 2. To get from 4 to 6, I have to add 2. To get from 6 to 8, I have to add 2, and so on and so forth. And so this is considered an arithmetic sequence because we're adding something every time. So in this self-check, we're going to be talking about if we're going to determine if a sequence is arithmetic or not, and then finding things, the common difference, or like the common difference is what it's adding every time or what it's subtracting every time. And then we're also going to find certain terms in the sequence. So let me give you one other thing and then we'll start the examples. And this thing that I want to talk to you about is the formula. So the formula for an arithmetic sequence that we want to know is A sub n is equal to A sub 1 plus D times n minus 1. Now I'll go through all what this means. This A sub n is the nth term. So we don't necessarily know what n is, but we're going to be able to get n. Sometimes it'll ask you for like the 100th term. And so in that case, n would be 100. If it asked you for the 85th term, n would be 85. And then A sub 1 is your first term. So your first term is the very first term in the sequence. In the example sequence above, that first term would be 2 because that's just the first number that appears. And then D is what we call our common difference. And so our common difference is what you're adding or subtracting every time in the arithmetic sequence. And then that last variable N is whatever term I'm trying to find. So again, I'm going to say just term number. So if I was trying to find the 100th term, then I would plug in 100 for n. If I was trying to find the 70th term, I'd plug in 70 for n, and so on. And this formula we're going to use to find different terms in the sequence, but that's not for the first two examples. We'll use it for examples 3 and 4. So now let's start with the first example. On the first two examples, what we're trying to do is decide if the sequence is arithmetic, and then if it is, we want to find that common difference. So my first example says 4, 10, 16, 22, ... Okay, so what we're going to do is look for what it's adding every time, if it's adding the same thing every time. So the easiest way to do that is to look from 4 to 10. What would I have to add to get from 4 to 10? Well, in that, I would have to add 6, right? Now we're going to check all the other ones and make sure that they're still adding 6. So to get from 10 to 16, what would I have to add? Oh, I'd have to add 6. To get from 16 to 22, I'd have to add 6. So because all of these things say that we're adding 6 each time, that means that it is arithmetic. So we can call the sequence arithmetic. Because it's adding the same thing every time. Now, if it wasn't adding the same thing every time, then it wouldn't be considered an arithmetic sequence. Then the next step is to find the common difference. So the common difference is what you're adding or subtracting every time. Well, good news, we already found that because we know we're adding 6 every time. So my common difference, which we say is D, is equal to 6 because I'm adding 6 every time. Okay, cool. Let's look at the next example. So the next example is 3, negative 3, negative 13, negative 24, ... So once again, we're going to see if they're adding the same thing or subtracting the same thing every time. So to get from 3 to negative 3, well, we're going more negative, which means I'm subtracting something. And in this case, we're subtracting 6. And then, excuse me. Now let's go from negative 3 to negative 13. So from negative 3 to negative 13, I would have to subtract 10 to get from 3 to 13. And then from negative 13 to negative 24, I'd have to subtract 11. So we have -6, -10, and -11. This means that we're not subtracting the same thing every time, which automatically tells me that this is not arithmetic. And because I know it's not arithmetic, then I can't find the common difference and I'm done. Okay, so for the next two examples, we're going to be looking at sequences still, and these ones we already know are arithmetic, but this time they're asking us to find the 23rd term. So when I say the 23rd term, that means that if I continued this sequence and I continued to add the same thing every time until I had 23 numbers, that 23rd number would be my answer. So there's a couple of different ways you can do this. The first way is to just figure out what you're adding every time and then continue to add until you get to the 23rd number and then get your answer, which is totally fine. But sometimes it takes a long time. Like, instead of asking for the 23rd term, what if I asked you for the 90th term? Well, that would take you a long time to get 90 numbers, right? So the other way we can do it is with that formula I showed you earlier today, which is a sub n is equal to a sub 1 plus d times n minus 1. So with this one, what we can do is we can just plug in all of our information, and then our a sub n would be our 23rd term, as long as n is 23. So when we use this formula, the easiest thing for me to do is finding my common difference, or what I'm adding every time. So I'm going to start it from 10 to 13. What did I have to add? Oh, I had to add 3. Then from 13 to 16, I added 3. From 16 to 19, I added 3. So because I'm adding the same thing every time, I know it's arithmetic. And this tells me, because I'm adding 3, that d is equal to 3. Now, the other things that we need to know is a sub 1. And a sub 1 is my first term. And the first term in the sequence is just the very first number that shows up, which is 10. And then we also need to know n. N is the term that I want to find. So I want to find the 23rd term, which means that n is 23. Okay, so now I'm going to plug all of that information into my formula, which would give me a sub 23, because remember our n is 23, so this part is telling me I'm going to find the 23rd term, which is what I want, is equal to a sub 1. Well, we know that's 10 plus my d, which is 3, and then in parentheses n minus 1, which gives me 23 minus 1. And now from there, I can just plug that into a calculator. So 10 plus 3 times 23 minus 1 gives me 76. So the 23rd term in this sequence, the writing and talking at the same time, is 76. 23rd term is 76. Once again, I could have written out, I could have continued to add 3 onto this sequence until I got to the 23rd term, but this was a little bit easier, a little bit faster to use that formula. So let's go to the fourth example, which is the same thing. We're going to just give you a new sequence, but now, and still want to find the 23rd term. So my new sequence is 7, 0, -7, -14. And what we want to do is and we're going to use that formula, a sub n is equal to a sub 1 plus d times n minus 1. And then we want to know all of our information. So the first thing I want to find is d, or what I'm adding or subtracting every time. So to go from 7 to 0, I had to subtract 7. So I'm going to put a -7 there to represent that I'm subtracting 7. Then from 0 to -7, I'm subtracting 7. From -7 to -14, again, I'm subtracting 7. Because I'm getting more and more negative, I have to subtract rather than add. Which means that d is equal to -7. Now my a sub 1 is my first term, which in this case is +7, and then my n is still 23. I want to find that 23rd term. So now that I have the 23rd term, now that I want to find the 23rd term, I'm going to plug everything into my formula, which gives me a sub 23 is equal to my first term, which we decided was 7, plus d, which is -7, and then n minus 1 would give me 23 minus 1. Okay, so now I'm going to plug that into a calculator, which gives me that the 23rd term is -147. And there we have it. This is how we deal with arithmetic sequences.